Hello, and welcome to my Apollo 13 disaster presentation. Was Apollo 13? Apollo 13 was supposed to be the third mission to land humans on the moon following the historic success of Apollo 11 in 1969 and Apollo 12 later the same year. On April 11th, 70, astronauts Jim Lovell, Fred Haise, and Jack Swigert launched from the Kennedy Space Center aboard a Saturn V rocket. The mission's destination was the Faro region of the Moon, an area which scientists wanted to study because of its unique geology that was presented there. For the first 2 days, everything went smoothly for the crew. They carried out their routine tasks and prepared for the lunar landing which was planned ahead. But around 56 hours into the mission, disaster struck, which one of the spacecraft's oxygen tanks suddenly exploded, which this singular event crippled the power system's life support and navigation capabilities of the spacecraft. With this event happening, they had to cancel the remaining of the mission, which the only hope the crew had to return was the free return trajectory method, which allowed them to use the moon to basically let gravity carry them back towards Earth, which was extremely risky. Despite the odds, though, the careful teamwork between the astronauts and NASA's mission control on Earth, Apollo 13 made it home safely. Because of this mission, it is remembered not only as a failure, but what NASA calls the successful failure. Mistakes made. Oxygen tank failure. One of the biggest mistakes that led to this disaster was the failure of oxygen tank number 2. The causes weren't simple, they were layered and built over time. For one, the thermostat switches inside the tank were damaged during earlier ground testing. On top of that, the tank's wiring was fragile and the fan inside the tank has been overheated during a pre-flight check, which weakened its components, which these small problems might not have caused immediate trouble, but together they did create a dangerous situation. Eventually, during the mission, pressure built up inside the tank, beyond what it could possibly handle. The result was a massive explosion, not only destroyed the oxygen tank, but set off a chain of reaction that threatened the lives of the astronauts. Mistakes made. Power system failure. When the oxygen tank exploded, the problem wasn't just the lack of oxygen for the astronauts to breathe. The spacecraft's fuel cells, which produced electricity, also depended on the oxygen tank to function. When the tank was destroyed, the fuel cells were effectively shut down. This meant that Apollo 13 lost its main source of electrical power. Lights, instruments, and other critical systems started to go dark. To make matters even worse, the explosion physically damaged parts of the service module, which held the spacecraft's essential systems. The only way the astronauts could have stayed alive was by shutting down almost all of their systems and using the lunar module, which was originally designed for just 2 men to live on the moon, as an emergency lifeboat for all the crew members. Mistakes made. Attitude control problems. The oxygen tank explosion also caused what are known as attitude control problems. In space, attitude doesn't just mean mood. It means the spacecraft's orientation or angle. Because the service module was venting oxygen gas into space, the spacecraft began to rotate in unpredictable ways. For example, imagine trying to steer a car with the wheels spinning out of alignment. That's what Apollo 13 was dealing with, except in this case, it was dealing with it in the vacuum of space, where every tiny push matters. The astronauts had to fight to keep the ship stable, and this made navigation extremely challenging. In which this case was, precise angles were absolutely necessary to stay on the narrow path back to Earth. Even being a few degrees off could have sent the spacecraft past Earth's atmosphere, dooming the crew. This made every decision about navigation tense and critical. Actions to avoid future disasters. After Apollo 13, NASA knew changes had to be made to prevent another disaster like Apollo 13 from happening again. Engineers went back and redesigned the oxygen tanks to be stronger and safer. They also used better wiring and insulation to reduce the risk of shorts. Fans and heaters inside of the tank were redesigned to operate more safely, along with adding a pressure relief system, which was added so that the tanks could never build up pressure to the point of exploding again. Beyond the tanks themselves, NASA also overhauled its testing procedures. Equipment was handled more carefully and testing was more thoroughly done. with more frequent checks before the launch. The idea was to make sure small problems didn't add up to the point of catastrophic failure. The big lesson here was simple. Rushing or cutting corners during preparation could literally mean life or death. From then on, NASA placed much greater emphasis on safety checks, redundancy, and careful testing, which also affected other areas of the engineering fields and other industries. Effects on engineering after Apollo 13. The story of Apollo 13 also left a lasting impact on engineering as a whole. It taught lessons that went far beyond just space travel. First, it showed the importance of focusing on the end goal and working backwards to solve problems step by step. This way of thinking is now a standard approach in engineering and problem solving. Second, it's highlighted the value of modular design, creating parts and systems that can be repurposed if something goes wrong. On Apollo 13, equipment had to be improvised and repurposed in ways never intended, and the spirit of flexibility remains a key of engineering principles today. It also underscored the need to plan for emergencies, even those that seem unlikely. Apollo 13 proved that when the unexpected happens, preparation can make the difference between survival and tragedy. Finally, the mission reinforced one of the most famous lessons of engineering and crisis management. Keep calm and work through the problem. In other words, don't panic, break down the issues into steps and solve it logically. These lessons are still applied today, not only in aerospace, but also in the product design, medicine, crisis management, and almost every other modern engineering field. Conclusion. To sum it up, Apollo 13 did not complete its original mission of landing on the moon, but what it did do was arguably far more important. This mission demonstrated the resilience of human integrity, teamwork, and careful problem solving under extreme conditions. It also reshaped the way engineers think about design, testing, and safety. The failures of Apollo 13 forced NASA to raise its standards, and those improvements have helped guide space exploration for decades. The mission proved that even in the face of disaster, success can be found, which is why Apollo 13 is now remembered not only as a tragedy narrowly avoiding said disaster, but also the successful failure that changed engineering for the better. Citation page. These are the resources used to create this presentation. It also is worth to note that I only use ChatGPT for scripting and citation formatting, which the citation formatting was done in MLA format. Thank you for viewing my presentation. Thank you again.